Hello, welcome to our webinar on Closing the Loop, an introduction to the circular bioeconomy, brought to you by CIFER, the Council on Food, Agricultural and Resource Economics. My name is Gal Hachman and I am the CIFER Board Chair. It is my pleasure to be moderating today's webinar. Next. It's CIFER's mission to translate high-level research and knowledge to a diverse audience that includes policymakers, elected officials, and federal administrators. When we demonstrate the value of the profession to these groups, the Council increases public appreciation for research, extension, outreach, and academic programs in agricultural and applied economics. Next. Before we start, I'd like to provide just a bit of background on the topic that we will discuss today. Modern environmental challenges demand a shift from the traditional take, make, dispose model to a sustainable circular bioeconomy. This approach uses biological resources efficiently to eliminate waste and decouple growth from environmental harm. Join this introductory webinar today as a preview to the practical tools and concepts we will explore in depth at the AAEA pre-conference workshop on Saturday, July 25th at Kansas City. Next. CIFER assembled a panel of experts to discuss their work, starting with David Silverman, who holds the Robinson Chair in the Agricultural and Resource Economic Department at UC Davis. David's research analyzes water, innovation, supply chain, agriculture, energy, and the environment. He has studied the adoption of irrigation technology in water markets in California, the economics of pesticide regulation, the political economy of agricultural biotechnology, and the design and potential of the bioeconomy, the economics of biofuels, as well as the alternative crops, and the economic impact of COVID-19, the pandemic. Next. Dr. Madhu Khanna is an ACES Distinguished Professor of Environmental Economics in the Department of Agricultural and Consumer Economics and Alvin H. Baum Family Chair and Director of the Institute for Sustainability, Energy, and Environment at the University of Illinois at Urbana-Champaign. She received her PhD from the University of California at Berkeley. Her research is at the intersection of agricultural, energy, and environmental economics and has led to more than 180 peer-reviewed publications that are widely cited. Next. Aaron Webb, PhD, PE, is a distinguished researcher at the Oak Ridge National Laboratory and serves as lead of the Bioresource Science and Engineering Group and Laboratory Relationship Manager to the Department of Energy, Alternative Fuels, and Feedstocks Office. Aaron is a fellow of the American Society of Agricultural and Biological Engineers and serves as the chair of ASABE Circular Bioeconomy Systems Institute, CBSI. Next. Before we start discussing the topic at hand, I just want to introduce a few housekeeping rules. I'd like to remind you that you can submit your questions to the speakers in the chat box at any time. We collect those questions at the end of the presentation, of the third presentation, and then we'll share them with the panelists for their response at the end of that presentation. Next, please. Now we're ready for David. Our first talk our first one out of the three will discuss supply chains and circularity. David, the floor is yours.
Okay. Oh, good evening. It's a big pleasure to be here. And I would like to speak about supply chain and in the circular bioeconomy after I define what the bioeconomy is all about. Next. Okay, what is the bioeconomy? The bioeconomy consists of all the sectors of the economy that rely on renewable natural resources and modern science to produce goods and services. For example, it include it produce food, fuel, chemicals, carbon sequestration, environmental services. Now, we can distinguish between the traditional bioeconomy, that was an economy till the 1700s, and the modern bioeconomy that is built on the discovery of DNA, information technology, the internet, and a lot of the other modern technologies that we have now. Next. Next. Now, the bioeconomy has many subsectors. The green bioeconomy include agriculture and forestry, producing food, fibers, and fuel. It benefits from biotechnology and precision farming. And a key element in this green bioeconomy is, in addition to agriculture as food, is the future use of lumber as a building material, not only for small residents, but for high rises. By using lumber, we can move away from using steel and cement and move to a more sustainable system, and we have the technology. Now, the second element is the blue bioeconomy that rely on algae, fish, other creatures to provide incredible number of products. The amount of material that can be produced from the sea is much bigger than we know because we only now start working on it. Then we have the white bioeconomy, biomanufacturing of pharmaceutical and fine chemicals. Uh, Instead of using a chemical that comes from oil, we can use chemical that we can that we can obtain from plants. Plants are the most sophisticated chemical labs that we know, and they are all natural. Then we have the micro bioeconomy that use the microbiome to produce a lot of solution and medical solution. And then you have the brown bioeconomy, which is a circular bioeconomy that take advantage of new technology to recycle a lot of residues from agricultural production, residues from food and other products through a wide variety of processes. Next. Now, the bioeconomy is essential for the greatest challenge of our time: climate change, loss of biodiversity, and loss of land, and it can be a source of rural well-being. A lot of money that go now to non-renewable resources can go to the farm sector. Farming can be expanding to be the biggest industry because it can provide fuel, it can provide building material, as well as the traditional food and medicine. So to me, the bioeconomy holds the key to both addressing the challenge of climate change and building a much, much stronger rural sector in the US and around the world. Next. Now, you can design the bioeconomy by designing its supply chain. A key element in any economy are supply chain. And generally, supply chain include the feedstock that can be a renewable resource, can be wood, it can be plants, it can be animal that will be processed and converted to some final product, and then it will move to the consumer. I think that supply chain are the crucial element of every economy, and I think that we haven't learned and understand supply chain as much as we can. We can design sustainable, reliable, and robust supply chain that can produce the key economy product and would divert material from the lab to the consumer in a way that will be more enjoyable to the consumer and more profitable to the producer. Next. Now we can speak about three types of supply chain: the innovation supply chain, the product supply chain, and the marketing supply chain. The innovation supply chain is moving product from the lab to provide a new technology to the manufacturer. So in America, we have a very sophisticated system where universities provide a lot of new knowledge that result in that is developed and result in a product that is ready to go. Then you have a strong manufacturing sector that produce a product at different level, and then we have the marketing that move it from the company to the to the consumer. This supply chain are symbiotic in a sense that feedback from the consumer goes back to the innovators. The innovation can done both in the public and private sector, and the game between the innovation supply chain, product, and marketing reflecting demand and supply and are crucial for the evolution of the bioeconomy. Next. Now, when you see it in plant breeding, where all the three chains are working together. Next. So if we want to see it in the bioeconomy, animal waste can be used to produce proteins through black soldier flies. Wood residue can produce biofuel, and crop residue can produce a lot of chemical. We can design the bioeconomy so that everything will be circular, so we have less pollution. And the key element is to coordinate things. So when you have new feedstock, you have the equipment and the machinery to utilize it. Next. Now, a key element is to regulate based on benefit and risk, not to ban. Banning something like GMO is a big mistake because you cannot build a bioeconomy without using more technology. We have to be very careful about our regulation, but we cannot only regulate based on risk alone. We have to balance risk and benefit, and that will allow us to have new product and a healthy bioeconomy. Next. So, to some extent, economics is really crucial to build a bioeconomy. It's an integrative discipline that allow to take information from all disciplines and put them together to generate trade-off. It allows us to assess feasibility and prices, allow us to design supply chain. Next. And economists assess trade-off, identify constraint, and assess way how to evaluate and improve the bioeconomy, design institutions and policies. Next. So what does it leave us? The bioeconomy the bioeconomy is now is taking advantage of new life and information sciences, natural resources, and it can be a key for sustainability, both more economically viable and strong rural sector and control of climate change. It requires government investment in R&D and policies that are reasonable that allow entrepreneurs to produce new products while protecting the environment. And again, I return about the importance to regulate on benefits and risk and taking into account trade-offs. Thank you for the opportunity. Bye.
Thank you very much, David. Very interesting. Next, we will have Madhu Khanna discussing circularity and its limitations. Madhu?
Thanks, Gal. Good afternoon, everyone. It's a pleasure to be here today to talk about some of the policy implications for transitioning to a circular bioeconomy. Next. So over the last century or more, we have really developed a very productive agriculture and food system that harnesses technology and processes to utilize the natural resources that we have to meet our needs for food and feed, fuel, and materials. And the focus has been on developing systems that use biological processes and advanced technologies to maximize productivity and profitability and lower the costs of meeting our increasing demands. But this current economic and production system that we have can be described as a linear economic system because we extract resources, we make products and use them, and then we dispose them off. and the disposal into the environment causes enormous environmental degradation. This waste is generated at every stage of the supply chain, and it leads to numerous environmental and human health problems. And as in the U.S., it's estimated that we spend about $1 trillion a year on food and meeting our demands for agricultural products. But when we consider the impacts of this food system on different parts of our society, including rising healthcare costs, climate change, biodiversity loss, water quality implications, then the true cost of food production is at least 3 times larger, so about $3.2 trillion a year. Next. And so this is really creating an imperative to moving towards a circular bioeconomy. And the idea of a circular bioeconomy is to combine the principles of circularity, which emphasize reducing environmental degradation by increasing resource efficiency. So intensifying our agricultural production, but doing so sustainably, recycling and reusing waste, regenerating our natural systems such as our soil health by adopting better practices, and maintaining the value of products and materials and resources in the economy for as long as possible, instead of disposing them off through single use. And combining this so that any waste that cannot be reduced, recycled, or reused can be converted into bioproducts and bioenergy using modern biotechnology. So using residues and other plant-based, other feedstocks, we can produce numerous products, including biofuels, plant-based proteins, bioproducts, and that can displace the need for fossil fuels. Next. So there are numerous technological pathways that exist for increasing circularity on the farm, and these include precision farming, which can reduce the over-application of inputs. Currently, there is a significant over-application of inputs like nitrogen and phosphorus in agriculture, with low efficiency with which these inputs are used, that may range from about 30 to 70%, which means that a significant part of those inputs are actually being wasted into the environment and are contaminating environmental quality. Additionally, we are heavily reliant on fossil fuel-based inputs, both directly as energy into our production system, or as for inputs like fertilizer and pesticides. And replacing these with biological and renewable inputs, or with new AI-based technologies that can mechanically do farm operations that used to previously rely on chemicals, can significantly reduce environmental harm. Redesigning cropping systems to include perennials that can then provide feedstocks for bioenergy systems and the bioeconomy is another opportunity. Climate-smart regenerative practices like cover cropping and no-till, biochar, and others. And so there's many technologies that already exist that can help us to increase circularity on the farm. Next slide. Similarly, there are many feedstocks that we can use that are currently being produced or have been shown to be very productive for meeting the needs of the bioeconomy, and then using them to produce various types of products. So food crops are currently being used to produce biofuels in many countries, including the US. There's significant opportunity to diversify and produce energy crops, which are high yielding, yield a lot of ecosystem benefits, but also are costly and need to have investment and establishment. Crop residues are also readily available, but we have to be careful how much of these we actually use without causing negative impacts on other environmental services. And then we have choices about the types of bioproducts, bioenergy, biochemicals that we use these for. So the bioeconomy offers significant opportunity, but we have to think about how to transition from a linear economy to this bioeconomy. Next slide. And so these different choices that we have, for example, for feedstocks, have numerous impacts that can vary depending upon what we are trying to measure. So, for example, corn is a readily available feedstock for the bioeconomy. It can moderately reduce carbon intensity, but it can have negative impacts on soil carbon and cause nitrogen runoff and indirect land use change and so on. But if we grow corn with climate smart practices, then we can have much greater carbon intensity reduction. We can increase carbon stocks, lower nitrogen runoff, and also have less negative impacts on land use, but the cost goes up. Similarly, between looking at crop residues and energy crops, they vary in the kind of extent to which they can provide environmental benefits and also what the cost of these is going to be. And so there are various trade-offs that need to be considered, and that is where economics can really play a role in helping us to identify what is the right mix of these feedstocks, and also how do we create incentives for those feedstocks that can improve environmental quality and do so without raising cost significantly. Next slide. So as we think about how, transitioning to a linear economy, it's important to understand what are some of the reasons why we see the persistence of this linear economy. And one of the major reasons is that many of these initiatives that we're talking about are highly capital intensive. They need upfront investment in feedstocks that are more environmentally friendly, in infrastructure, and refineries, recycling facilities, and so on. Many of these initiatives also have long payback periods. The feedstocks like energy crops are perennials and have a 15 to 20-year lifespan. There's lots of technological uncertainties as we look into as we try to invest for the future that can hamper investment. There's a chicken and egg barrier. Should the refineries come first, or should the feedstocks come first? And risks of these getting returns and so on. So in order to transition to the circular bioeconomy, we really need to have policy incentives, market incentives, and long-term stability of these incentives. Next slide. So existing policy incentives, even though one of the reasons for the existing linear economy is that we're not pricing waste, and it is free to dispose of waste to the environment in most cases, generally speaking, pricing waste would be one approach to creating incentives for the circular bioeconomy. But currently, we have a whole suite of programs like conservation programs in agriculture. We have mandates and tax credits to promote the bioeconomy. And often these policies are not connected and don't work synergistically in order to achieve the goals that we need in a cost-effective manner. Next slide. So we really need to think about how we can design policies that overcome the barriers, including the behavioral and societal constraints for adopting various types of circular and climate smart practices. And these types of policies include subsidies that can cover upfront costs, crop insurance to cover the downside risks of transitioning to novel feedstocks, low interest credit to overcome the effects of uncertainties about investment, mandates to provide assurance of demand for circular and bioproducts. And we may need to have multiple policies. So a single policy by itself may not achieve all the goals that we need. And so we have to combine mandates with low carbon fuel standards and pricing policies in order to create a more complete set of incentives to transition to a sustainable bioeconomy. Next slide. And one approach is to do that through biofuel policy. So biofuel policies can be modified. So they create incentives for farmers to adopt circular practices on the farm, including that can lower carbon intensity and be more regenerative. Next slide. So in summary, a bioeconomy can induce a range of feedstocks and products, and these products and feedstocks offer various trade-offs in terms of their impacts on different environmental services and their impacts on food and fuel prices and other economic impacts. And so here, policies can really play a critical role by rewarding the provision of ecosystem services and making sure that the bioeconomy that we transition to is in fact environmentally sustainable by relying upon high yielding feedstocks that provide those types of ecosystem services and minimize negative impacts on food and fuel prices. And even going beyond policies to develop markets so that ultimately we can have market-based incentives that can reward and induce this transition. And of course, we need policies that consider the political economic effects of this transition so that we can mitigate those barriers for this transition. So I'll stop with that and turn it back to Gal. Thank you.
Thank you very much, Madhu. Very interesting and very insightful. With that, we'll move to Erin, which will discuss one of these systems and some of these feedstock and how we can actually reach a commercial and viable solution. Erin, the floor is yours.
Thank you. So I really appreciate the invitation to be with you all today. I'm representing the engineering perspective as we think about the circular bioeconomy, and it's so critical that we do so in conjunction with our partners in other disciplines. So I'm excited that you've invited me here today. Go to the next slide, please. So David and Madhu did a great job defining what circularity is and the need for it. I'm going to give you our perspective within the Circular Bioeconomy Systems and Institute in ASABE. And that is that it's a system of systems. So there are systems around processing, there are systems in the post-production and then in the harvest side, in the production side, also the in use, whether it be food or a fiber product or even a fuel product. So each of those has its own systems, and then we have to connect those together, and that's our system of systems view of it. There's a number of resources. These are just a few that we are concerned about: energy, water, CO2, nitrogen, and phosphorus. And each of those work in different ways in these systems. So we need to track and understand how they flow through and understand how we want to utilize each of them in each segment of the entire chain there. And so we want to design out waste and pollution. These are goals based on that CBSI has developed. Design out waste and pollution, keep products and materials in use as long as possible, regenerate natural systems, and then provide economic benefits. That last one is a real key that I know you guys understand very well in the economics community. We have a number of resource flows, as I mentioned, and then we also have other resources when we think about the community, labor, etc. Outcomes not only for the landowners but also for the community and then the utilizers of the whatever's being produced, and then the society in general. So all of those come into play to understand these systems of systems. So it's incredibly complex. You can go to the next slide. Putting on another hat, and from Tennessee, I want to share with you some of our work at Oak Ridge in conjunction with University of Tennessee, and how we're thinking about a specific region in Eastern Tennessee and Northern Alabama where this could play out in a particular way. So this is just one example of circular bioeconomy. Of course, we have, as David pointed out, we have so many different examples in the food industry and food waste and the waste industry in general, within forestry, etc. This one is taking grasses, switchgrass and miscanthus primarily, purposely grown for biomaterials that would be utilized in a number of industries, but one is automotive, which is an important industry in the Southeast, important manufacturing industry, to design recyclable by design materials utilizing local biomass sources for the automotive industry. So this is important and a unique opportunity because we're able to design an entire value chain from the ground up. And then that means we can tailor the plants to provide the feedstocks to make the materials that we want. And recyclability is a major design factor, not just utilization and not just thinking about the first product, but thinking about the cascading uses after that. So the second product and the third product that material might go into. And then, of course, it will have an end of useful life. And at that point, it can either be composted, well, there are a number of options, but for example, composted and reapplied to the land, or turned into energy and then utilized as a bio-based source of energy for different parts of the segment. Within that entire system, we also need to have really clear understanding stakeholders across the value chain need, And we need to understand the cost and the value and the economic impact, as well as the environmental impact. And that's that bottom segment there, the impact analysis via TEA and LCA. In our particular system, this is a large partnership, started as a partnership within UTORI, the UT Oak Ridge Innovation Institute. And then this week, we're really excited that NSF is also going to be supporting this overall concept with their NSF Engines program. And that the UTORI program brings together the UT Institute of Agriculture, the UTK main campus, Oak Ridge National Lab, where I'm at, local industry, our vast abundance of bioresources in the region, and local workforce. And now we're able to bring in more industry and other partners through this NSF Engines program that's going to start soon. You can go to the next slide. So I'm going to switch back to my hat for my ASABE hat now and point out, I think the Tennessee example is a good one, and there's lots of others of how we need different partners to be able to achieve circularity. We simply cannot, not one discipline, not one organization can do it alone. And so that's the mission behind the Circular Bioeconomy Systems Institute that has been developed within the American Society of Agricultural and Biological Engineers. The mission there is to advance education, professional development, and innovation for developing sustainable circular bioeconomy systems. And the vision is that CBSI will be a leader in creating a healthy planet by utilizing these systems for food, feed, forest products, and renewable resources. We have 4 working teams. One is on innovation, second on developing metrics and standards, third on organizing meetings, and the fourth to publicize and promote. Now, primarily, these are ASABE members, but we also invite non-members to be a part of CBSI. And we have a number of non-members who are part of CBSI and lead some of these working teams. So we're really excited to have collaboration already within the Institute. You can go to the next slide, please. But our vision is quite a bit bigger than just with a community within ASABE. And so that's why we're starting to think more of a network of organizations. And we view AAEA as a key partner. And that is to develop a circular bioeconomy systems network that would include, and we could kick off with ASABE and CBSI, but it would include other partners as well. Cotton Incorporated is one that we has been really interested. Schmidt Sciences is partnering with us. And like I said, AAEA through the workshop next week. And then more recently, Solutions from the Land. But we welcome lots of other partners as industry and partners from universities, et cetera. And we already have a number of those. There's just too many to list here. And so I welcome anybody who's interested to reach out to me. You can contact me and we'll get you plugged in and connected. Our goal now is to, we have a good structure within CBSI, but again, to build partners and build collaborative activities that both organizations can benefit from. There will also be a summit, a meeting next May at North Carolina State University, and you'll hear more about that in the coming months that we'll invite folks to partner with as well, so we can bring together multiple disciplines to explore what circularity really means. I heard a quote earlier today that was, if you want to go fast, you do it alone, but if you want to go far, you build a team. And I think that's really important in this space of circularity, because in order to achieve that, it is a complex goal. It's a challenging goal, but it is one worthy to tackle. And as we do so, though, it requires a long view, and that's why these partnerships and these teams are going to be important. Go to the next slide, please. So one example of that was at the American Society of Agrobiological Engineers meeting earlier this week at our annual international meeting. We were joined by representatives from an organization called Solutions from the Land. They came to our meeting and gave a great talk by farmers that joined us on the center stage, and our audience loved it. Our audience of engineers loved it. They really liked engaging with these partners, and they also were able to announce the release of their report, which is available at that website, Solutions from the Land, that includes stories from around the world by farmers who are implementing circular practices. So it's a really inspiring report. I encourage you to check it out. It's really interesting to see how farmers in different parts of the world are implementing circularity, and some of the common challenges and some of the unique challenges each face and how they're dealing with that. So please check out that report from our partner, Solutions from the Land. And I believe that's my last slide.
Thank you very much, Erin. And indeed, we have a joint workshop next week on Saturday. We encourage anyone interested in this topic to join us. It is jointly co-organized by CBSI and CFAIR